Let's talk about chips, not the kind you eat, but the tiny powerful brains inside every piece of technology you own. For decades, the story of chips was all about making them smaller, faster, and more powerful, a steady, predictable climb that shaped the digital world as we know it. Each new generation brought more speed, more memory, and more possibilities. But in 2025, that climb has become a leap. We're not just improving chips, we're completely reimagining what they can do. We're in the middle of a revolution, chips that don't just calculate, but actually think, learn, and understand. They're inspired by the human brain, and they're changing the rules of what's possible. We call them nano-brain processors, the most exciting tech I've seen in years. These chips are designed to mimic the way our own neurons work, bringing a new level of intelligence to machines. Imagine shrinking the brain's billions of neurons onto a chip. That's the core idea. It's about packing the complexity of human thought into something smaller than a fingernail. These chips don't just follow instructions, they process information intuitively, like our minds. They can adapt, recognize patterns, and even make decisions on the fly. It's a fundamental shift in computing, unlocking AI that once seemed like science fiction. Now, machines can learn from experience, not just from code. Now AI isn't just in the cloud, it's in your pocket, your car, your doctor's tools. Everyday devices are becoming smarter, more aware, and more helpful than ever before. This AI can see, hear, and reason on its own, without needing the internet. It can process images, understand speech, and react instantly, all on the device itself. The era of cloud dependence is fading. Edge AI is here thanks to these new processors. That means more privacy, faster responses, and smarter tech everywhere. So, let's dive into the nano-brain revolution, what these chips are, how they're built, who's making them, and how they're already changing our world. The future is being assembled right now piece by piece. This isn't just an upgrade, it's a new category of technology, a turning point that will redefine what our devices can do. The devices we use are about to get a whole lot smarter, starting with this tiny, brain-like chip. Welcome to the era where your tech doesn't just work for you, it thinks with you. So, what is a nano-brain processor? Imagine a computer chip that doesn't just process information, but actually learns and adapts, much like the human brain itself. This isn't science fiction, it's the next leap in artificial intelligence hardware. A nano-brain chip is designed to mimic the structure and function of the human brain, taking inspiration from the way our neurons and synapses work together to process information, learn, and remember. Unlike traditional computers, which keep the CPU and memory separate, the brain and these revolutionary chips combine both in a vast network of billions of interconnected artificial neurons. This allows for much more efficient and flexible processing. When you learn something new, your brain's connections physically change, strengthening or weakening based on experience. This is called neuroplasticity, and it's the secret to human intelligence. Nanobrain chips are built to do the same thing. Their artificial synapses can strengthen or weaken, allowing the chip to adapt and improve its performance over time, just like a living brain. This is a huge departure from classic CPUs, which are excellent at following instructions and crunching numbers, but struggle with learning, pattern recognition, or dealing with uncertainty. Nanobrain processors thrive on ambiguity and complexity, identifying faces in a crowd, understanding spoken language, and learning from experience in real time. The nano part refers to the mind-blowing scale of these chips. They're built at just a few nanometers, thousands of times smaller than a human hair, using cutting-edge nanotechnology. This incredible miniaturization lets manufacturers pack billions, or even trillions, of artificial neurons onto a single chip, pushing us closer to the brain's own density and energy efficiency. The result is a smarter, more efficient way to compute, especially for artificial intelligence tasks that require learning, adaptation, and creativity. Traditional computers waste a lot of energy shuttling data back and forth between the processor and memory, creating bottlenecks and slowing things down. Nano brain chips process and store data in the same place, dramatically reducing power consumption and making them ideal for mobile devices and next-gen AI. That's why your phone can now run powerful AI features, like real-time translation or advanced photo editing, without draining the battery or overheating. It's not just a faster chip, It's a whole new kind of engine for the age of artificial intelligence, designed to learn, adapt, and evolve. This is the future of computing, a world where machines can think, learn, and interact with us in ways we've only dreamed of until now. Whenever a breakthrough like this happens, there's a race, and the competition for the best nano-brain processor is fierce. Tech giants like Intel, NVIDIA, and Apple are pouring billions into neuromorphic silicon, turning years of research into real products. But startups are shaking things up too. Companies like Synapse Dynamics and Cerebrum AI are pushing radical designs and quantum-powered chips. These newcomers move fast, take risks, and attract top talent. The result? Giants are forced to innovate. Fresh ideas are setting new industry standards. It's a dynamic, fast-moving field, and the pace of change is staggering. So, why do nano-brain chips matter for you? They make AI personal, instant, and truly helpful. Before, heavy AI processing happened in the cloud, delays, privacy concerns, and constant internet required. Now, your device does it all instantly, on the edge. Your phone understands complex sentences, context, and tone. No cloud needed. Data stays on your device, boosting privacy. Cameras analyze scenes in real time, delivering perfect photos. Real-time translation overlays text instantly. Beyond phones, smart homes, and cars, react instantly, making decisions on the spot. The lag is gone. AI feels like an integrated part of your environment. This is intelligence that's truly at your fingertips. What makes nano-brain processors possible? 3 breakthroughs: neuromorphic circuits, quantum pathways, and next-gen transistors. Neuromorphic circuits mimic neurons, using analog signals and spike-based communication, only firing when needed, saving energy. Quantum pathways let information move almost instantly across the chip, speeding up learning and training. New materials like carbon nanotubes and graphene enable ultra-small, efficient transistors. These advances allow billions of artificial neurons to fit on a chip without overheating. The result: brain-like architecture, quantum speed, and efficient design. AI models that once took weeks to train now learn in hours or minutes, right on your device. This is the heart of the nano-brain revolution. It's a leap in both power and efficiency. Where are these chips in action today? Start with flagship smartphones. Real-time photography, smarter assistants, and on-device security. But the impact goes far beyond phones. Robotics is transforming. Warehouse bots reroute on the fly. Delivery drones navigate cities solo. In agriculture, autonomous tractors target weeds with pinpoint accuracy. Healthcare is changing too. Medical scanners flag anomalies instantly. Prosthetics respond naturally. Even musicians and artists use nano-brain-powered tools for real-time creativity. The common thread: instant, context-aware AI that feels like a partner, not just a tool. Delay is gone. Intelligence is everywhere. This is the new normal. Building a nano-brain chip is nothing like making a traditional CPU. Instead of flat, two-dimensional circuits, these chips are three-dimensional and chaotic, like a real brain. Manufacturers use self-assembly nanomaterials, connect themselves into complex structures, guided by electrical and chemical signals. This allows for incredible density and overlapping connections. But it also means every chip is slightly unique. No two are identical. Instead of discarding imperfect chips, each one is trained to compensate for its quirks. The result: a family of chips, each with its own personality. Manufacturing now blends fabrication with AI training, a whole new paradigm. It's as much about growing intelligence as building hardware. As thrilling and promising as this technology is, it comes with real and significant risks that we can't afford to ignore. Every leap forward brings new challenges that demand our attention and careful consideration. Job displacement is immediate. AI-powered automation is already changing the labor market, replacing roles that once belonged to people. Many workers are anxious about their future, and entire industries may need to adapt or reinvent themselves to survive. Security is a growing challenge. These advanced chips can learn and adapt on their own, making their decisions hard to predict or audit. This opens the door to new vulnerabilities, from data breaches to sophisticated cyber attacks. The black box problem means we can't always see or understand how AI makes its choices, raising serious concerns about safety, transparency, and control. If we can't explain AI's reasoning, how can we trust it with critical decisions? As these chips get more powerful, their unpredictability grows. We're essentially building artificial brains that we don't fully understand, and that uncertainty can have real-world consequences. There's also a risk of a new digital divide. These chips are expensive, and early access may be limited to the privileged few, leaving others behind and deepening social inequalities. Ensuring broad, equitable access to these technologies is a major social challenge. We must work to make sure everyone benefits, not just a select group. To move forward responsibly, we need clear ethics, robust safety protocols, and effective ways to keep AI in check. Collaboration between experts, policymakers, and the public is essential. Ultimately, the future depends on how we manage these risks. The choices we make today will shape the world of tomorrow. By 2030, nano-brain processors will be everywhere, changing what device even means. Intelligence will be embedded in the world, glasses overlay info, homes adapt to your mood, cars become mobile offices. You'll teach your devices, not program them. In medicine, nano-brain robots could hunt cancer cells or repair tissue from within. Scientists will use AI co-pilots to accelerate discovery. Human AI teams will tackle the world's toughest problems. If we manage the risks, the potential is limitless. The nano-brain revolution isn't just about smarter gadgets, it's about augmenting human intelligence and solving problems we never thought possible.